Can you hear me? All right. Anybody know what's the catchphrase for the Hitchhiker's Guide to the Galaxy? The first two words? Yeah, don't panic. So basically, those are the exact same words that were floating in my head when I was asked to do or build up an IoT security program for a company, a Fortune 500 company. I was lost and I didn't know how to build it. My background was from application security, and I know right now it's quite a cold day and long day, but let's take it easy and unwind and go through an easier to digest topic, which is an introduction to IoT security and testing. So it's kind of cool that the culminating topic right now is sort of a mix between everything that was talked about earlier today. We are going to talk about hardware security, application security, threat intel, application development, and even incident response. So hello everyone. Good afternoon. Let me introduce you to a HITCHHACKER'S Guide to the IoT, a security from a perspective of a fast-moving consumer goods company. So, quick introduction. My name is Jerome de las Alas. You can call me JD. I'm from Atlanta, Georgia. This is my first time here in Charleston. It's a very, very good city and very pretty. I'm currently doing product security for Kimberly-Clark. For 12 years, I was an application security engineer. I came from Fortify on Demand before it was, or previously it was from Hewlett Packard. So basically, before cybersecurity, I was doing I was coding assembly for a Japanese company doing a laser measurement tools. So essentially, I was doing development work. But around 7 years ago, I was hired by Kimberly-Clark to build their own application security program. Right now, I'm focusing on IoT security. We're doing a smart restroom solution. So basically, for businesses to automate their PayPal tower dispensers and make it easier to track maintenance of restrooms. Outside cybersecurity, my interests are astrophotography, photographing the stars, galaxies, and looking at millions of years ago from the past. As you might have noticed, this presentation is play on words for Douglas Adams's Hitchhiker's Guide to the Galaxy, which I thought suits this walkthrough best because from a cybersecurity perspective, I felt like I was just hitchhiking my journey through IoT security because nobody knows how to build IoT security programs, especially from a non-technology company like Kimberly-Clark, right? So there was no surefire way to go through IoT security back then, a couple of years ago. And the whole IoT security landscape is still a mess until right now. There is no standardization, no security controls, unlike application security, which has OWASP, et cetera, and NIST, right? So basically, we're doing our best effort to mimic what we're doing from currently established security programs like web, network security, et cetera. So let's switch perspectives for a while. Majority of the talks today are from cybersecurity professionals, vendors that are providing security services to companies. But from my company, from my perspective, we are on the receiving end. It is our business that wants security from the experts. These are the color-coded chapters that we're going to go through to figure our way out or figure our way through IoT security. So our first tip, figure out where we are. At this point, we are aiming to figure out where we stand, what's our posture in the current IoT landscape for essentially all the IoT devices in the world. Kimberly-Clark, as you might know, is specializing on paper products like Kleenex, diapers like Huggies, and it is estimated that 1/4 of the world is using 1/4 of the world is using Kimberly-Clark products per day. So it covers quite a lot of people, but remember the pandemic when everybody ran out of tissue papers? Yeah, that was us. So why on earth would we run out of why on earth would we want to dive into a technology? We are a paper company, right? The short answer there is a market for it. Businesses want to automate. They want efficiency in their businesses, and that's why we're providing IoT solutions to for easier monitoring of their bathrooms or restrooms. And that was the point where we thought we needed to take a step back and define for ourselves what the hell is IoT and where would our products be in the ecosystem. We also had to evaluate our offerings and how to integrate security in the development of the product. In the next couple of slides, we'll go through the what, the why, and the how. So basically, these are just clippings of issues and growing concerns for IoT security since 2018 until recently. Consumers are slowly starting to be aware of IoT security, and as we move forward, I think it would start to get more visibility from everyone. I think worth noting here is the Google smart speaker fiasco here when they admitted that they kept a recording of users without the wake words "Okay Google." So it's kind of interesting for me. These are just small samples of IoT and connected devices from the more normalized ones like smart TVs, smart cars, smartphones, until the more absurd ones like smart salt shakers, smart sandals, smart toothbrushes. Everything is smart right now. There is a quote here from the Oxford Dictionary, which is it's a sample usage sentence from Oxford, which I found quite interesting, given that the first thing they thought about, aside from the transformation for IoT, is security. And then we had to evolve our way of thinking from a normal software development lifecycle to what we now consider a system development lifecycle. We had to look into emergent technologies and make new efforts to do security considerations for each. I broke down these pillars into 5 distinct items that we can separately test and ensure efforts on security controls and configurations for each. These are hardware and firmware. And just a side note, we have collaborated with our earlier speaker, Jake here from Ambient, and his team to get our hardware tested. I believe they did the methodology that he described earlier on one of our products. It's so cool. So communications and networks and protocols like Bluetooth Low Energy, cellular, MQTT, and of course we already have application security and mobile security kind of in the bag because we have established our application security programs way earlier before. And then there was a secure cloud configuration and hardening, which is also a bit new for us. And then we saw new and different risks and opportunities that we previously just kept at the back of our minds. We always find this meme funny because essentially when the hackers need only to be right once to measure their success, well, from a security perspective or from our perspective, anything less than 100% is considered faulty. This also means that considering that nothing is standard, there's no consensus way to protect IoT implementations, since there are thousands, if not millions, of permutations on how to build an IoT solution. And then when the product was prototyped, we had to establish a method to the madness. I call this a trial by fire. We were already there. There's no going back. We had to move forward, and so we did. I will walk us through each item and provide samples of how we approached it. Most of you might find this simplistic. I apologize for that, but keeping things simple is what helped us understand how deep should we go in terms of our security controls and our design. Our first tip is do a functional or normal baseline test first. I cannot stress this enough. If you have a device, make it work first like you're a normal user and not an actual hacker. There's no point in doing security testing if the product is not even working, right? So, for example, if you're testing a smart lock right here, see if it unlocks first. Download the application and try to unlock it normally. The next step is draw a simple architecture diagram with associated functions and mapping of what it does. RTFM, if you don't know how things work, usually these products have some details and technology on the technologies that they use in their users' manuals. So for example, here in the smart lock, they advertise that they have a mobile application, and you already have the hardware device, which is the smart lock. And we assume that the application is communicating through a cloud environment, and that's what we wrote here in our architecture diagram. And then do a discovery components when you open up the devices. Sorry, it's kind of cold. List out parts that are easily identifiable. Refer to user manuals and development manuals, and consult specific technical documents. Majority of these search engines are very, very, very helpful when discovering the usage and functions of the components. For example, when we open up a product, there's usually an engraved label in the microchip or microprocessor. Do a quick Google search for that, either through their FCC ID or their specific datasheets. Shown here is an ESP microcontroller, ESP32. It's a very, very common chip for internet-connected products. And interestingly, I noticed that our badge here also is using the same chip family. Funny, when you look at the badge here, there's a QR code that should contain information on when the chip was created or manufactured. And it should also contain the MAC address of the actual chip and other vital information that are in the chassis of the microprocessor. So once we get the data sheet, these should display the pins of interest, not Pinterest, but pins of interest that would probably we want to test. Pins like UARTs, SPI, JTAGs. That data sheet would also tell us which pin to pull up or pull down if we want a specific desired function. Data sheet should also tell us which pins are the VCC or the power pins, as well as the ground pins. It should also show the unique specifications of the microcontroller, such as the delays and the clocks, the timers, etc. Since we only have a limited number of pins in a microcontroller, sometimes the functions are multiplexed into different pinouts depending on the developer's configuration. Once we establish a method to the madness, we can expound on it to map an attack surface. So if you remember, this is the architecture diagram that we wrote earlier. What we can do is, since we have established these functions, what we can do is, these are the orange ones, we can write out the specific attack surface that are possible for the actual functions. For example, we have BLE lock here, which is the physical device. What we can attack is the firmware, physical security issues like essentially pulling or breaking the device itself. And then, for example, Bluetooth Low Energy, you can sniff and replay the traffic, like for using Ubertooth, etc., etc. So from a cloud security perspective, check if it is also susceptible to brute force or misconfiguration. Exposed API keys and tokens should also be considered here. And then we do our normal tests for each of the component. I mentioned a while ago, a few slides ago, the common go-to tools here from the different fields of security of penetration testing would be a great start. So for example, for hardware and firmware, we have Binwalk, microcontroller debug tools, and the applications. For communications, we'll have Wireshark, TCP dump, Ubertooth, GAT tool, etc. For web and mobile applications, we have the ever-reliable Burp Suite and Z-Attack proxy. This is where we exercise our creativity. For example, I was testing a prototype or solution at home, and I cannot, for some reason, sniff the traffic that it was generating. I ended up connecting my device to my Pineapple from Hack5, and then I executed a TCP dump from the Hack5 GUI itself. And then that's the only time I was able to do the TCP dump of the traffic, or the PCAP files of the traffic. The internet is also full of geniuses that already have the necessary tools associated with that specific hardware. For example, ESP32 here, if you search for the ESP tool.python, they actually have a Python script that can dump the actual firmware once you connect or find the actual pinouts in the device. This is where the actual title of this topic is. We hitchhike or we hitchhack from the geniuses from the internet and use their expertise and technology to for our own advantage. So some tips while working through a test, though. First, be patient. Sleep on it. Usually the answer is already there, but you just have to look at it from a different perspective. Start with the least invasive tests. Do not go gung-ho in dismantling the devices from your first test cases. This includes testing the default firmware and software before any updates are made or done. Do not break the device for now. My next set of tips include considering power supply and static electricity. From my past experience as a hardware developer, hardware is 10 times more worse to troubleshoot than software. Simple static electricity can break your device in a matter of seconds. Soldering and desoldering while the device is turned on could possibly overheat the sensitive microchips, possibly. Takes step-by-step pictures of or a video while you're dismantling the process. This brings back memories when I was a kid and being scolded by my mother for not being able to put back some home electronics that I dismantled. Those were the days. But also, when dismantling a device, be mindful of component orientation. Some specific electronic components, like polarized capacitors, might not work or might even destroy your whole device when you put it backwards. And then we go into the details of documentation. I know documentation is a bad word for penetration testing. But aside from the normal contents of a normal penetration test, we include some new components such as device versions, firmware versions that we tested. Also include the tests that did not yield actual significant security issues, so that next time when other pen testers do it, they would know which methodology that was performed from the previous test. So in summary, those are the tips that help us configure or help us figure where we stand in terms of capability and from a consumer goods manufacturing standpoint. Some tests we did on our own prototypes. some tests we had to test devices from the outside. Like if we were using an external component or external solution, then we had to test it ourselves as well. Now we go to the second tip, which is never ignore strategy for the sake of how fast the IoT environment or landscape is changing. Our current Chief Information Security Officer always tells us to skate where the puck is going. So basically, we look into the current IoT landscape and predict what would be the next trend, and so we can manage the security attack surface that's going to happen on that end. Yeah. So we also asked our business to let cybersecurity have a seat at the table in terms of decision making, and have some inputs from our end, because at the end of the day, whenever a product is breached, it's the whole brand or the whole company that's going to be affected. So also when starting, we had to reach out to different individuals, like our corporate strategists, our R&D business owners, to learn what they envision their product would look like. And from there, I worked backwards to fill in the gaps, like the necessary supporting documents. Standards like NIST, OWASP, IOTSF provided my baseline requirements. Special courses like the Atify one from Aditya Gupta and the SANS IoT security course helped me establish the required test cases. These courses also have the perk of having security test kits that we can practice on hardware for some of the hardware that we don't necessarily prototype, but we are curious on how it works as well. So shift left has been a buzzword for application security for quite some time now. Why not integrate it in the system development lifecycle as well? Note that we're still on the same theme here. Think of it as we're like on a spaceship and lost in a galaxy, and shifting left is course correcting and maneuvering our shift towards the left. DevOps right now has some integration with security automation tools like SAST, DAST, and software composition analysis. Some of these processes and integration can also apply to firmware development and how firmware is designed. SCAs, or software composition and analyzers in particular, can help build out the software bill of materials, which would immensely help in tracking threat, CVEs, and the actual component updates and frameworks that we have previously used. We also need to establish a threat analysis early so that we ensure that the necessary controls over each attack surface and attack scenario that we identify. So here is an example of the threat assessment snippet. First, we identify the type of threat, in this case, software, the leftmost part here. And then we establish the attack vectors and the impact. And then we establish the current status of the threat, whether it's mitigated or not, or whether it's still open. And then the rest is for the incident response and how can they tell if something goes wrong with the product. We can also use some industry standardization and recommendations like the MITRE framework here. We listed out some of the code for the actual threat that we found. Or simply, if you want to have a more quantitative approach, you can use the CVSS scoring for it. On point to our space theme, let us time or jump or time or space warp. This just means that we need to understand where's the balance between letting go of the security reins if you want R&D and innovation to flourish, versus when we need cybersecurity to come in. Obviously, we would want cybersecurity to be present in the final design, but we do not want a full-blown penetration tests on a sandbox environment, right? So the keyword here is seamless. Make it so that cybersecurity is not considered a roadblock, but rather a selling point for a product. So, oh no, we need to test our ship quick, press the red button. But oh, is that the orange button? So basically, the red teams are critical in testing our security posture, but we would want involvement with our developers, and that's where the orange comes in. We want a mix in yellow, which is the developers, and join it with the red team, making it orange. So historically and usually developers are and security professionals are at odds when it comes to product development. Usually they come, yeah. So from my standpoint, we just need to talk to them, make the developers understand the value of our security controls, and bring to the what our security controls bring to the overall posture of the whole solution. Make them realize that it would take a lot more to fix if the actual vulnerabilities are found late within the production environment. It wouldn't also hurt to listen to their sentiments. Number one tip that I saw here is make the developers implement an update or a mechanism to roll out patches over the air would be preferable. The last tip in the guide is be friendly to the other non-security beings. Yeah, these includes marketing, sales, legal, and business partners. The cybersecurity organization cannot do everything alone. Turn the tables and sell the value of security for them. For example, say to the marketing and sales team that they can slap a third-party security assessments or attestations in their marketing materials so that when they're selling their solution, the consumers are more comfortable with the product that they're selling. Scare them nicely about the regulations and compliance like GDPR, CPRA, etc., etc. And lastly, reverse the culture. Usually, a big company ingests IoT solutions for their own corporate environment, right? We ask our vendors, for example, if their solutions fit our cases or some of our use cases. Now, we have to have a shift in perspective. We are now selling a solution to other companies. The mindset should be, if I was buying my own solution, what are the security features that I would expect for everyone to be comfortable with buying my solution? Yeah. So yeah, that was my last slide. I have in here some of the resources that I used throughout my whole journey, and yeah, thank you.